So what we're looking at is these formulae, use of formulae in engineering, which is a key thing that you're going to be able to do. If there's one thing that you carry away from this Unit 4, this engineering mathematics, it will be using formulae. Because that's what engineers do. You know, they get the formula from a textbook or some sort of table, and then they get the values, they look up the values that are required, they put the numbers in and work out an answer. So you will be using formulae if nothing else. Okay, so we've got to find the pressure. So we've got to identify the right formula. Well, I've given you the formula, so there it is. But sometimes you've got to find the formula that's required. So that depends on what you know and stuff like that. So that's can be difficult. So I've got this formula. I want to find the pressure, so I need to know h, which represents the depth. So we're given that as 3.62 meters. I need the density, which is 13,600 kilograms per cubic meter, and I need to know what g is, the acceleration due to gravity, which is a constant for this planet Earth, 9.81 newtons per kilogram. Now, before I put the numbers in, I check something. Before I put the numbers in, what's that? Good, thank you. You check units are consistent. What do I mean in this context then? Right, the same sorts of units. Kilograms, look at G, it's in newtons per kilogram. So the density needs to be in kilograms per cubic meter. Look at this unit cubic meters. That means any heights or depths must be in meters. Units are consistent. If I've looked up in a table of values column what the density of this particular liquid is, and this is actually the density of mercury, then it needs, I look at the unit, it's in kilograms per cubic meter. So then I know all masses, if mass is involved, must be in kilograms, and all lengths must be in meters. So thank you, units must be consistent, and in this particular case they are. So to use the formula, you ask yourself the question, is the formula in the correct form? What do I mean by that? Is the formula in the correct form? I've been asked to find the pressure, and the formula reads pressure equals something. If I've been asked to find the density, I would have to rearrange this formula to read density, or rho equals something. So is the formula in the correct form? A lot of the time, yes, it is, because we're after it. Okay? You're just using the formula, not having to rearrange it. But if it's not in the correct form, we've got to rearrange it. And then once we've got the formula in the correct form, are the units consistent? And we've talked about that. Okay. And then when we've done that, we put in the values. If I was setting this out, I would now write the formula. I've done it at the top, so I'm not going to do it again. But then I would write P equals, what's H? It's 3.62 times density, which is 13,600, times gravity, which is 9.81. No, I've not quite written it in the way the formula is. It's H rho G H, but when you're multiplying, it doesn't matter, does it, what order? So that's the same. I put the numbers in, and then I get my calculator out, and I write the answer down. Josh? Josh, isn't it? Yeah. What's your answer, please? Ollie, sorry. 0.92. And the unit, anybody know what we measured? Pascal, thank you, well done. Pascals, PA for Pascals. We'll write the unit. There's an issue with that answer though, Oliver. What's that issue? If I was an engineer asking you to do this, I wouldn't be that happy with this answer. That's one point, yeah, we'll come to that. Yeah, not in standard form or engineering. I might be expecting that, but that's not that bad, 482,000 pascals. No, that's not what I was after, although more on that in a minute. Look at the numbers I put in, and then look at the answer. If I had to set up a meter or some sort of device for that pressure, that means I'm going to try and enter a pressure of 482,965.92 pascals. Is the answer that accurate? Why did you stop at 0.92? Did you run out of room on the calculator? So if there had been more spaces on the calculator, I could have gone on and on and on and on with this answer. Where do you stop? There's an issue around accuracy. Look at the accuracy of the numbers I put in. Can anybody comment on? That's at 2 decimal places. What about this one? Well, there's the decimal point is at the end. So for this one, there's a decimal point. So there are no decimal places. 2, 2, none. The decimal points, the decimal places aren't the important thing. The significant figures are the important thing. They're the measured values. This first one is measured to 3 significant figures. I've measured 3 figures. This one is measured to 3 significant figures. The 2 zeros at the end are just because it's not 136, it's 13,600. So the zeros have to be there to put those 1, 3 and 6 in the right columns. Yep. How many significant figures in that one? No. 3. 3 measured values. 3 significant figures, 3 significant figures, 3 significant figures. What is the accuracy of my answer? 3 significant figures. The rule of thumb is your answer will be to the same degree of accuracy as the least accurate figure you put in. So in this case, they're all the same, so that won't come into it. Or one more. So if this was, say, 2 significant figures and these are all 3, then I'd use 2 significants or maybe 3 because these others are 3, but not more than that. So write this answer to 3 significant figures. And I'll pause that for a second while you do that. We've not talked about. So 48300 pascals, but then what we do is this at the end, 3SF. We state that we've written it to 3 significant figures. So somebody who's looking at your answer knows you've rounded this to 3 significant figures. And then when we've done that, we might, put it into standard form. We tend to not use standard form, but engineering notation, which goes in 3s. So 483 times 10 to the 3 pascals. That's in engineering notation. To 3 significant figures. We use engineering notation because 3s mean we could then do something else. Instead of writing times 10 to the 3 pascals, what's 10 to the 3 of something? 483 kilopascals to 3 significant figures. Okay, so that's why we tend to use engineering notation, because that fits in with these prefixes. Okay, that would be an excellent answer to give to your boss in an engineering works. What's the pressure that I've got, that I'm going to get if I go down to a depth of 3.62 meters in this column of mercury? What's the pressure going to be, please? And you work it out. You present your results like this, and there's your final answer. It's going to be 483 kilopascals to 3 significant figures, not 482,965.92 pascals. Can you see the difference between those two when demonstrating competence to someone at work? Hello, George. Yeah. Quarter past. Give me 10 minutes. Okay. Questions?